Hello people, my name is Andrzej and today we're going to talk about event sourcing or source eventing, depending how long did you party last night. To be honest, I would like to focus more on challenges, issues, problems, hard decisions with event sourcing adaptation. And I'm quite aware that probably most of you are already quite familiar with this kind of architecture, but there is no presentation about event sourcing without this set slide, so let's get it over with. So in classic systems, you are saving your entity aggregate as the most current state to database. Where in event sourcing, state on database not exist. I mean, you can save a snapshot of state for example, performance reasons, but this is totally optional. The source of truth in event sourcing are events. And once you apply events from the beginning, you will get exactly the same state as on the left side of the slide. But with events, you will also get more business information. For example, some item was added to the order and then removed from it. This looks like a pretty important business information. Maybe this user should get some voucher for this item. Maybe we should send him a newsletter with a replacement for this item. Maybe this information is completely irrelevant for your business. What is important here is that you as a developer should not decide what's important, what's not. You should store all business events and provide necessary data when needed. So why event sourcing? As I mentioned, complete log of every state change in the system. This is especially useful for business, but for you as a developer as well. Why? Debugging. Many times when I was trying to find a bug, it was necessary to reply event by event to narrow the scope of the investigation and finally find the bug. And without this, it will be much harder and sometimes impossible. Replying events is not only useful for finding the bug, but also for fixing the state. So once you have a history of all state changes in the system, it's really, really easy to fix the state. But let's be honest, you can achieve those two things without event sourcing. The real reason people invest in event sourcing solutions are those 2 points, so scalability and performance. And of course, I will cover this in details later, but first we need to talk about one more acronym, which is CQRS, so Command Query Responsibility Segregation. In CQRS systems, handling commands and reads is separated from handling queries and reads. Handling commands and writes and queries and reads. And this separation is not only on a software level, but also on a hardware level. So different repositories, different deployments, different hosts, different databases, etc. And yeah, you can implement CQRS without event sourcing, but implementing event sourcing without CQRS, it's quite pointless. I mean, you can, why not? But it will be really, really hard to squeeze maximum potential from event sourcing architecture without CQRS. That's why those two are implemented more or less together. Okay, now the question is how to implement event sourcing application. We have 3 options here, so custom implementation, some library, or framework. If you look at event sourcing from a domain perspective, this is quite trivial architecture. We have only 3 basic building blocks: commands, event, state. And just 2 methods to implement on state, so process command and return list of events, apply event and return new version of the state. And if you go with fold left and apply, you will get the most current state. Easy, right? So most people recommend to implement event sourcing by yourself from the beginning. This is partially true, but your application will be production ready when you deliver few more set but require features like snapshotting, failover, recover, so what should happen in case of some restarts, crashes, some support for debugging, sharding, serialization and schema evolution, concurrency access, etc. And implementing this by yourself is a recipe for a failure, trust me. I know that every programmer would love to create his or her own event sourcing framework, but please don't go this way. Just use something that was already implemented and tested by many users, many programmers. Unfortunately, using any framework library has its hidden host. So here's a basic JPA implementation. So we have some entity with business code and some JPA annotation. It looks okay, or not. Actually not. what is the problem with this code? You just mix two really important responsibilities. First is your business code, obviously, and some annotation with instructions how to persist it. So someone could argue, so what's wrong with it? If I remove all this annotation, the code will be the same. True, true. But this is a really easy example. And in all tutorials, you will find only easy examples, and then you need to implement something from real life. For example, I would like to use a map of maps in my domain entity. I suppose that translating such field to a JPA will be problematic. That's why in most cases I would choose something simple or something more JPA compatible. And this is a huge problem for me. Personally, I hate such compromises where my infrastructure layer is dictating me how should I implement my domain layer. No. As Uncle Bob said many times, persistent should be only a plugin to your domain. And the same story goes with event sourcing frameworks. So here's an example from Axon framework. So you have business code mixed with technical annotations. And the same story with Lagon framework. So user entity extend persistent entity. And if you check the imports, some JSON formats, on my domain level, I don't care about JSON. I don't care about any framework. I just want to implement my business use cases. That's it. So how to deal with this? Back to the beginnings and proper packaging. You can start with something very easy, where you have a domain package with all the event sourcing domain-related stuff like commands, event, state, and application package. Basic application package is the place for the library framework. If you want to check the full example, just go to my GitHub. So in this case, your users from an event sourcing implementation will be free of any imports to nasty frameworks. Code will be trivial or not. It will be exactly as complex as your domain. What is trivial here is how you will test it. You don't need to launch Spring Context to test this code. You don't need to launch Actor System to test this code. Just simple unit tests. How cool is that? So once again, application package for all the set stuff, and domain package for domain logic, domain validation, and imperfect world zero event sourcing framework imports. So I'm saying very often library framework. What's the difference? Usually, removing library from your application should be much easier than removing a framework. But the cost of this is that you will need to handle more stuff manually by yourself. And at the same time, you will gain a lot of freedom. And a good example could be akka-persistent versus Lagom. Lagom is a full-blown event sourcing framework. You just need to put commands here, events here, and Lagom will do the magic for you. Where akka-persistent is one level of abstraction below. Lagom is based on akka-persistent. So akka-persistent will provide you all the necessary technical requirements for good event sourcing application, but you will need to care about more stuff by yourself. Which choice is better? That depends. But I suppose this is a story for a whole new presentation. And actually, maybe the choice is somewhere in between. Maybe akka-persistent typed is better. Maybe Acre library, which will be a topic of the next presentation, is a better choice. As always, it depends. Because this presentation is about akka-persistent, so let's go further with this particular library. Here's a classic, very popular event sourcing implementation with akka-persistence. So we have command service, which is the place for the library, and which is responsible for saving events in a transaction in a strongly consistent manner to our event store. And next, we have a projector, which is usually implemented with akka-persistent query. Different read models, query services, exposing read models via some API. Nothing unusual so far. Maybe except this part, command services are not simple stateless services. Those are actually stateful services. Why? Well, in event sourcing, once you load an entity in memory, it will wait in memory to handle next command. And basically, that's why event sourcing is so fast, because everything is in memory. The problem with this approach is that you cannot load the same entity on two different machines, because you will lose consistency. And in case of handling writes, you must follow single writer principle. So how to scale a strongly consistent service? The answer is sharded cluster. So usually akka-persistent is used with akka-sharding, akka-cluster. Are there any problems with this architecture? Only two, both of them in the same place here. So first problem is load. If we launch hundreds of projectors, we can increase database load, and this way degrade our write performance, and for our writes we want to be as fast as possible. Also, there is a problem of lag. So how often should I query my database to check if there are some new events to process? Each 3 seconds, each 1 second? I can imagine many systems when an additional 1 second in eventual consistency is simply not acceptable. So how can we improve this? We can introduce another piece, which is an event bus. And I know that many people will say that this is a very bad idea. As definitely Greg Young will disagree with me. Okay, if you have 5 or 10 projectors, then don't go with event bus. It will be an overkill. But if you have hundreds of projectors and you want to scale really fast, and you don't want to expose your event store as a whole to all your microservices, but you still want to share events with them, then sooner or later you will go with event bus, because this is a very nice buffer between your event store and whatever want to read your events. So what are the benefits after such change? Definitely you just decrease the database load, because right now you just need a single query to check for new events, then you will populate them to event bus. And now launching hundreds of projectors, it's not a problem because you will use good event bus, like Kafka. So this is actually a pretty normal use case to handle hundreds of projectors. Also, you will gain streaming capabilities, so you can play with reactive streams between your event bus and read models. So if you have too aggressive projectors, they will not kill your read models. Unfortunately, the problem of lag still remains. So how often should I query my database? Maybe each millisecond. Actually, there is a better way to fill event bus with new events. And how about sending them in a fire and forget style just after saving events to our event store? This is the fastest possible way to fit our event bus, but of course some guarantees are required. So at least once delivery here is a must, you cannot lose any event. Also, events order must be exactly the same. You can create duplicates, that's not a problem, but events order must be remained. And how to implement this, you can read on our company blog, where there is an article with a lot of details. So I would recommend to read it, because we need to go to the next big question. We know what we want to implement, how, or at least the direction, and or at least the options. And next big question is where to store events. And in case of akka-persistent, you have basically two options: relation database or Cassandra. And relation database seems like a safer choice. Everyone knows how to use it, how to set up it, how to maintain it, even on production. So it's safer choice. Not really. It depends on your load, because relation database were designed to work on a single host, and vertically scaling a single host will be a problem sooner than later. Also, you might face a very interesting problem. So here's a snippet from akka-persistence-jdbc implementation. I will just extract the most important part. So we have select statement from events journal where tags like some tag. And this query will be really, really slow, but not right away, so that you can spot the problem before using it, using this on production, but after some time when you generate enough events. And adding an index on this column will not help, because we have like expression that starts with % and index will be completely ignored. So, surprise. That's why I would recommend to use, or at least to analyze, distributed databases like Cassandra, because you will get partitioning by design. Your data will be spread across all Cassandra nodes. Replication by design. In case of some node failure, you will always be able to read your events from a different node. And leaderless architecture, so no single point of failure. Any node can handle any query. Optimize for writes, so just two nodes will handle 100,000 transactions per second. And if this is not enough for you, then you can always scale it horizontally. Okay, so we know where to store events, now how to store them. And we have a lot of options here, so plain text serialization, binary serialization, and I know that most of you will choose JSON anyway, but let me show you some alternatives. First, let's compare binary serialization with plain text serialization. So, for sure, plain text serialization is human readable. This is very convenient. In case of binary, some additional step of the serialization is necessary to analyze your events. On the other hand, plain text formats, especially JSON, have some problems with numbers precision. Very, very nasty bugs. Just follow the links from the table. By definition, binary formats are more compressed, so you will save a lot of disk space. The actual benefit depends on your events model, but so in our case, it was from 60 to even 70% of saving on the disk space, which is a huge gain. And most of the benchmarks are pretty consistent right now. Binary serialization is simply much faster than plain text serialization, which shouldn't be a surprise actually, because in case of plain text serialization, a lot of additional steps are necessary to serialize and deserialize something. And the last point, very, very important, so schema evolution support. This is important because it will allow you to versioning your events without typical versioning pain. And in case of binary serialization, this support is on a completely different level than in case of plain text serialization. Okay, so clearly binary formats are pretty nice options. Now the question is, which one should we choose? I would need to speed up a little bit. So right now, choice comes down to basically two options. So Avro versus protocol buffers. Both are fine when it comes to multi-language support. They will support the most popular languages. Both are really fast. Payload size is almost the same. Both will provide you with full compatibility support, so backward compatibility and forward. So adding a field, removing, renaming is not a problem, almost. But the support is really, really nice. So what's the difference? Now, the difference is in schema management. So in Avro, you will need a reader and writer schema to deserialize something, which might be a problem sometimes. But also the difference is in the overall impact on your domain. So in Avro, you will write definitely less boilerplate code. But the cost of this is that Avro can leak into your domain. Where in protobuf, your domain can be perfectly separated from your serialization mechanism, but the cost of this is that you will write a lot of boilerplate code. Which choice is better? It depends. Actually, stay tuned because I'm preparing another article about this stuff with a lot of details, so just observe our company blog. And we need to move forward. So right now we know everything. What we want to implement, how, where to store events, how to store them. So let's implement some event sourcing. Where? Everywhere. No. This is the first major problem with event sourcing adaptation. The architecture is really powerful, but at the same time quite costly. So there is no point in event sourcing everything. In your core domain, you should choose even some subset of this domain, probably the part which makes money. And maybe this is the place for event sourcing, maybe not. So remember about the slide, and now we can move to more classic problems, like memory consumption, which shouldn't be a surprise because so many stuff is loaded into memory. Yeah, out-of-memory exceptions are quite boring. Just don't do anything stupid with your state and you should be fine. Perfect advice. And maybe also remember about passivate idle entity after in case if you have a lot of aggregates. And this brings us to the next problem, or maybe question. Should my state be immutable or not? By default, of course, immutable. It will be much harder to create out-of-memory exception, and it will be much easier to managing the state. But as always, it depends. So when we are using immutable list, we were able to handle 17 operations per second, and then we switched to good old-fashioned Java tree map and 2,200 operations per second. This difference is so huge that it cannot be simply ignored. That's why we go with mutable state. Still, there is an actor which is a guard to our state, so I'm pretty comfortable with this decision, and I know that only one thread will access my state at the same time, although I need to be more careful, and I cannot simply return my state as a response. I need to create a copy before. Also, if you are using save snapshot method, then create copy as well, because this method is asynchronous. Okay, next problem, handling duplicates. Oh my god, this is a nightmare in a distributed systems. So let me tell you a story. This is a fairyland. This first unicorn is called exactly once delivery, and the second one is called transaction between two aggregates. None of them exist. You know, I'm a happy father of twins, so when I'm saying that there's no such thing as exactly once delivery, trust me, I know what I'm talking about. So when someone is telling you that if you use this or that, you are able to get exactly once delivery in a distributed system, either this person is lying to you or not telling the whole truth, which is basically the same. So how to handle this? First, why duplicates? We have at least once delivery on our producer side, but even if you are able to filter out duplicates, which is not such a big problem, our projector, which is basically a consumer, should be ready to handle duplicates anyway, because of some crashes, restarts, some repartitioning on our event bus side. So in distributed system, you should try to achieve something called effectively once delivery. And the easiest way to do this is to update your read models in an idempotent way. If you can idempotently change your read model, you're fine. You don't have to care about duplicates, because processing the same event twice will not change read model. Unfortunately, some read models aggregate something, a counter, which is a good example. So if you process the same event twice, counter value will be wrong. In this case, you need to deduplicate your events, and you can use a sequence number for that. So you need to track it. Actually, each event should have a sequence number which is a monotonically increase long. And before you update anything, you need to check. If the sequence number is +1, then okay, this is the next event, I can update my read model. If it is +0 or -1, this is a duplicate, I need to skip it. If it's +2 or more, then it means that you have a gap in your events and the problem is on your producer side. And yeah, this is the recipe for the duplication. There is one gotcha here. You need to update your read model in transaction and save your current sequence number. And this transaction must fail if you use the same sequence number. Relatively easy to implement in SQL database, but surprisingly, not all read model storages support this kind of transactions. For example, Redis. Yeah, you can save two pieces of information in transaction in Redis, but this transaction will not fail if you use the same sequence number. So be careful. In this case, there is always an ultimate solution. Just drop the whole read model and recreate it from the beginning. And this is actually the topic of the next slide. So a broken read model. When you can break your read model? Two reasons. First, software reason, so some bug in the code, handling or mishandling duplicates, and hardware reason. Some read models are more fragile than other ones. Once again, Redis is a very good example. In case of Redis crashes, you can lose some data. Actually, a lot of them, depending on configuration. So in this case, yeah, you can always rebuild the whole read model from the beginning. This is an awesome feature in event sourcing I used many times. But sometimes processing billions of events might take some time. In this case, maybe a snapshot and the latest events will be okay for you, and this will definitely speed up read model recreation. But also you can take advantage on your event bus and do something called manual offset management. So in this case, in one transaction, you are saving your read model update and current offset from event bus. And in case of some crash, you just need to read the latest successfully saved offset and process events from these offsets. In case of hardware failure, this is a recipe. Okay, so multi-aggregate transactional update, second unicorn. If you ever face the use case that you need to update in transaction two aggregates in event sourcing system, please stop. And first, rethink your aggregates boundaries. Maybe your aggregates are too thin, and if you simply combine them together, you will eliminate this problem very easily. Sometimes your aggregates boundaries are fine, and you still need to handle this use case. And in this case, in the distributed systems, forget about distributed transaction. The only way to do this right is to apply compensating action. And compensating action will be a topic of the third presentation in this event sourcing slot. So again, I will speed up a little bit. Okay. Maybe I will just mention that compensating action is usually implemented with Saga pattern. Those are really easy concepts to understand, but not so easy to implement. Saga should be persistible. There will be always some time window limitation. Events order should be relevant. And because of this, compensating action must be commutative. So you can apply compensating action first and then the actual action, and the state should be correct. Sometimes this is quite tricky to implement correctly. A few more links about Saga. And yeah, in the final version of our architecture, we are using sharded cluster. And with sharded cluster comes very specific problem, which is a split brain. And split brain is when your cluster, because of some failure, creates two smaller clusters. And load balancer have no idea that something bad happened because all nodes are working fine. And in this case, you just lost your strong consistency, and single writer principle is broken because you have two aggregates with the same ID loaded on two different machines. And fixing the state after such failure required a lot of work. Sometimes it's not even possible, so some data can be lost. That's why don't forget about split brain strategy when you are using akka cluster. And a few more best practice when it comes to cluster. So prepare very good monitoring and alerting to know exactly what is going on with your system. Prepare a lot of failover tests, some crashes, random restarts, blocking traffic, etc. Cluster should be deployed also on dev and staging environment just to test it more. And be careful with health checks. Do not restart nodes in the cluster if this is not necessary. For example, usually when you lose a DB connection in a stateless service, it's a good idea to restart the whole service. In a cluster system, I would simply wait for the DB without restarting nodes over and over again. And keep it as small as possible. If some functionality can be moved to a stateless service, just do it. Managing 3 cluster nodes is much simpler than managing 15 nodes. And summary of this whole presentation. So despite all these problems, I still think that event sourcing is a really, really awesome architecture, and akka-persistent is a really nice piece of code. Just take some time and understand schema evolution of your events command state. I'm not talking about hours here, I'm talking about days. Trust me, this will save you a lot of time later. And eventual consistency is your friend. Don't fight with it, just learn how to deal with it. Scaling is complex, no magic here, so launching Cassandra, Kafka, Akka cluster and more is it's not a piece of cake. It will take some time and some work, but the reward will be proportional to the effort. This whole concept of event sourcing is basically turning your database inside out. And this is a very, very interesting way of integrating many microservices in a complex system. And the last point, so once you create your first application, which core is basically processing log of messages, events in this case, you will realize that all big players are using the same technique, Twitter, Netflix, Facebook, etc. And most of the DB engines is using exactly the same technique. Because this is the recipe for a really fast, really scalable, elastic distributed systems. Definitely worth to try, definitely worth to expand your skill set with this knowledge. Thank you very much.